let's quickly also look at, before we move on, also look at the cosine function, how that looks. And as you can see, there's a symmetry in the circle. So the variation of the x coordinate has to be somewhat similar to how the y coordinate changes, right? Because both x and y, its circle is symmetric. So if you remember, cosine 0 is 1, right? So this is cosine. So cosine 0 is 1. Cosine 90 is 0. Cosine pi is -1. Cosine 3 pi over 2 is 0. And cosine 2 pi is 1. Right? And just to help you recall, cosine is the x coordinate. So at 0, when theta is 0, it is 1, right? When it is pi over 2, then x coordinate is 0, right? So pi over 2 has 0. When it is pi, x coordinate is -1. When it is 3 pi over 2, x coordinate is 0 again. When it is 2 pi, x coordinate is 1. So this is one period of the cosine function. Is also 2 pi. Because 2 pi means you went around the circle once, correct? But you see what the difference is? The sine was starting from here. Sine was starting from 0. The height was 0 here, but x coordinate was 1. Right? So sine starts like this, and cosine starts from 1. So actually, if you observe carefully, it is the same as the sine function, but it is shifted. If you shifted the sine this way, by how much? Pi over 2. Then you will get cosine. So do you know a transformation that shifts a function left? Suppose I have f of x, right? So what should I write here? That will be the same function but shifted left by pi over 2. So f of x plus pi over 2 will shift it left by pi over 2, right? So sine theta is wherever it is. If I want to shift it left by pi over 2, what should I write? Sine of theta plus pi over 2 is the left shifted version of sine theta, and we see that is actually cosine theta. Okay, so there is a relation between cosine theta and sine theta. Cosine theta is sine of theta plus pi over 2. This is actually one of the identities, trig identities. But here you can see it in the graph. Right? And let's say I replace this theta plus pi over 2 as alpha. So suppose theta plus pi over 2 is alpha. Then what is theta? Alpha minus pi over 2. So I could write this as cosine of alpha minus pi over 2 is sine alpha. See, this gives us an interesting way to convert between sine and cosine. So if I have, let's say, sine of 120 degrees, right? I can write it as sine 90 degrees plus 30 degrees, right? And 90 is pi over 2, right? So now you know that sine of 90 plus theta is cosine theta. So this is cosine 30 degrees. You can convert between sine and cosine like this once you know these identities. Okay, but you don't need to worry about this right now. Just know that if you have a graph of the sine function, you shift it left by pi over 2, it becomes the graph of cosine.